Here everybody, today we will do another video and it's going to be a quick video on transformers. And it's going to be on a specific transformer that is called, has a couple different names, has, some people call it high, high leg, yeah. Some people call it center that. So So this transformer, this specific one, we'll do another video eventually, probably about open deltas. But in this case, it's going to be just a normal delta with basically um, what's it? High leg. So let's say, for example, that we have um, it's going to be. Let's say, for example, we have something like this, right? All right. So then we have another one like that. Hopefully it's kind of straight. Then we have another one like that, right? So I think I have to bring this little more to the side. Okay, so as we know that we can call this A, call this B, call this C, right? Okay, so from this point we can have line. We can have a line like this, right? So it's a three-phase system. Okay. So we're missing something here, right? So, Paul, we're missing the values, right? With the engineers, we have to deal with numbers, unfortunately. Okay, so we have, you can put this, A, B, C, right? You can say that, you can say that this phase is right here. Each phase is 240 volts. 240 volts per phase. Okay, so that's per phase, right? 240 volts. So delta, normal delta. We know that the normal delta is not neutral. So therefore, we only see 3 wires, right? You take your the voltage meter and read from this point to that point, it's going to be phase A to B, B to C, and C to A, right? Take the voltage from this, you will find that for voltage different from A to C is going to be 240. You take the voltage meter from this point to this point, you know it's going to be 240 from B to C, and from C to A, you're going to get 240. Okay. Now, this is, let's see that we have a look. And for example, let's say that this is a secondary part of the transformer. We have primary here, we have source, right? We have a source coming in, and then there is a primary, but let's say you only dealing with the secondary. And the reason why I'm saying this is because the center tap, most of the times, is in the secondary. And it's called a high leg. Now, this is what is a very interesting in this type of transformer. Like I said, you read from here to here, 240, 240, and 240, right? No problem. Makes sense. Why? If you take the voltage meter, right, let's say for example, okay, so now you have 240, right? 240, 240, 240, but then this system is going to be only good for big, it's going to be for good for drivers and maybe washing machines with 240 volts, electric ranges and water heaters and what else? PC units, right? You can plug this 240 volt into the computer because you can blow it up. We can do something. We can do this high Lego center time. So we do that. Well, the transformer, we have something right here. We have in this coil, in the coil, um, and the coil will have something to top it off. We'll have something like this, maybe something like this. And you tap it from the center, right? So in this case, you got a 1, 2, 3, 4, 5. Well, it's not exactly in the center. I have to do another one. And do I feel like I do another one? Right? So 1, 2. So there are 1, 2, 3, 4, 5, and 6, right? So that's from here. So we can tap this one. Even it's a little point where you can bring, you can tap. And what do you tap it from? Okay, so okay. You tap it from here, and we call this neutral. Neutral. Yeah. This is an interesting part. You have to go to 40, 240. You can go here, right? You two, how if you snatch up, mean that you will have 120 volts here and 120 volts in here. Let me just move this so it's more clear. This V0. So 120, 20, right? Now this side is stacked. That's what we mean by center gap. This is what happened. So the question next, this is a good question. You get 120 between the neutral and and phase A, V or C, and you can add 20 microns. You cannot do that. That's the problem. So technically, so let's say that, I mean, you don't believe in magic, right? I don't. I believe in numbers. I believe in reality. Right? But if you think something about this, um, you can see that this center tap. So the question is, we get 120 volts. Why I don't get 120 between these two anymore? I'm sorry, 240. There is something very, very, very interesting going on. This one, so this right here, dump it down. See, can you see? Now we see two triangles, and you see two triangles side by side, like a forming a diamond, right? But these two triangles, actually, we have some geometry going on here. Some Yeah, it is geometry and trigonometry, but to make it simple, we just can keep it in geometry. So we take this guy. Let's say that if you cut that into the center by dropping that down, you have right here, right? From this point to this point, you get this 120. Is it really 120? That's the question. Is it really 120? It's not 120. Now, you can match this. You do it here to here, 120, 120, right? But you got it off into 40. And the interesting part in this case, when you do the math. So let's do it for example, right? Let's work this out. What do we see? We see a triangle, right? And we know two sides. We know this and we know that. We don't know this one. Okay. So if I had another color, I don't know if blue would be able to see, but if you put A here, a small a, actually, let me just, because it's kind of confusing now because I got an A and B here, so let me just do L1, O1, L2, L3. Let me do A, B, and C. What did I confirm go inside the delta? Two triangles, right? But I'm going to deal right now just with one of them. Just so that this right here happen to be that it's not 120. As you can see right now, logically will make sense, right? It's divided by 2, we get 120. But it's not like that. Okay. So let's think about this. A, B, and C We have a triangle, and we know that this side look like the hypotenuse, right? And this guy right here look like maybe side A, and it's side B in triangle, right? So we take the two sides, and we say, no, this is not. Hopefully I get one that works better. Okay, so we have A squared plus B squared is equal to C squared. The Taylor theorem, my favorite formula. Okay, so so let's do this. So we know C, we know A, we don't know B, right? C is equal to 240. B, actually no. A, B is equal to, just the square. So, so A is equal to 120. B, we don't know. C is equal to 40. Okay, so now what I do is what? I replace the values, right? And I say, well, 120 squared, 120 squared plus B plus B squared is equal to 240 squared. Right. Now, we do solve for B, right? We square this guy. We do 120 square. Of course, it's going to be 144 0 plus B squared is equal to, that's going to be double, so I guess it just multiply by 2, whatever. But 240, 240 squared is going to be, is going to be 55,007, 5,000, 57,600. Yeah. Interesting, isn't it? Let's solve for this guy. Subtract that guy to the other side, right? We get. So we know. So it's equal to 43. So now look at this. So B B squared equal to 43, 200. Okay, now, okay, so take the square root of this, put that in the square root, and I get, I got 208.84. Actually, 207, sorry. So B, which is side B, this guy right here. Actually, let me just make it B is equal to 207.84, which is approximately 208. 208 volts. Look at that. Something that you can actually make the feed off lower devices, right? Matter of fact, the one connected system, that's what most of the one for the residential, that's what they are. But in this case, it's a delta. And we found out that it happened to be that weird number. That's why when you read phase to phase on a system like this, with this high leg, you will see that the voltage is kind of crazy. It goes anywhere from 138 volts. It can go up to very close to 200 volts. So this is the center tap, um, center tap delta transformer. Thank you for watching, and remember right here, this is the engine. This is Engineering Academy, and I will say right here, a Trump support right? And and Fox Fox News became now fake news. So Fox News decided to get rid of Tucker Carlson, one of the guys that he was not like a real. I mean, well, how can I say it? He was not on either side of the aisle, right? He was a good, I would say, anchor. They decided to get rid of him, right? But Fox News became now fake news The good thing though, you notice over here, you already had the first letter. Good name, right, I guess. They didn't have to complete too much. They already have the first letter for their name. So this is the new name for Fox News now. Fake news, fake. And YouTube and making sure that if you don't understand my broken English, hopefully you understand this. Thank you for watching. Remember, we learn something every day over here because Jesus is good. Thank you for watching.